Welcome to qnawire.
In this problem, we're going to go back and look at problem 31 and look at the exergy destroyed. So let's see here. Again, we have our low pressure side is at 20 kilopascal, so we can get the entropy at the inlet and the exit of the pump, which is isentropic. And then we can go back and get the entropy at the inlet and the exit of the turbine, which is also isentropic. And then we can get the entropy in this problem. Let's see here, 31. What did we have there? That was a reheat cycle. So then this would be the entropy and entropy at the inlet and the exit of the second part of the low pressure turbine, right? So if you remember that, if you go back and look at that problem, it'd probably help you out. So let's see here. So we know the heat transfer in. We had this reheat cycle. So we have heat transfer in during the main boiler, kind of coming in from the pump, and then coming in from the turbine. We have some more heat transfer in from that phase. And then we have heat transfer out in the condenser, and we can again go back and look at the problem and we derived all these. Again, we have a low temperature side of 295 Kelvin and a high temperature side of 1500 Kelvin. Now, the exergy destroyed in the, let's see, this would be the pump, and then this would be the turbine, the two turbines from the high pressure and the low pressure turbine. That's all zero because they're adiabatic and isotropic, so we have no change in the exergy and no entropy generated in those, again because we're assuming they're ideal. Now we have basically exergy destroyed in the, let's see here, this would be in the these two things are parts of the boiler. So in the first part of the boiler that's coming from the pump, we get exergy destruction of 1110 kilojoules per kilogram. And then the exergy destroyed from the steam coming from the turbine and then getting reheated is another 104.6 kilojoules per kilogram. So then we have the exergy destroyed in the pump, and that winds up being again, this would be heat. No, sorry, not in the pump, in the condenser. So in the condenser, we have heat transfer out. So the change in internal entropy in the fluid, and then from the heat transfer, and that winds up being 240.6 kilojoules per kilogram.